Hello, Tomasz Onyszko, as already said. I will have a pleasure to entertain you for 45 minutes, I hope. As always, technical issues. Just let me, yeah. So, disclaimer number one, this is not technical talk. It will be about technology, but don't expect any command lines, whatever. So, if you are disappointed already, there's plenty of technical talks here, but you're already tired of it. Second, at the end or in the materials, you will find that this is mostly based on the work of this gentleman, which is called Simon Wardley. And to be honest, for me, that was one of the most enlightening and useful tool I ever learned. So I hope afterwards you will understand why and you will be able to apply it. Myself, Tomasz Onyszko, briefly, I'm a CTO for a company called Predica. Strangely, I work mostly with Microsoft, so Cloud Native and Microsoft, that doesn't go along together. I am MVP. You can find me on a Twitter, blog, vlog, my personal, onyszko.com. It's easy to find. So first, serverless is made of servers. You saw it already, but this is the obvious truth. There is nothing like a magic. It's basically a computers. But let's define what we are talking about as serverless. Because there's a lot of buzzwords around that. So for me, and I really like this definition, serverless is an application which brings a value, but doesn't cost me anything to run outside of storage cost. So I have an application, it has some value. When somebody is using it, it costs me. If not, well, I maybe have some storage. But it's really important to take a look at this, why I will try to answer this by the end of this talk. But let's start with something which is maps. I want to explain you the concept of the map and what's the deal with the map and how it matches to serverless and how you can use it in your daily life to make a lot of decisions. So first, what is the goal? Like, what is the goal of doing something? Let's talk about this gentleman. It's a Dwight Eisenhower. He has a goal of win the war by invading Germany from England and taking over the Germany, briefly. And to do this, he needs a strategy, like every one of us. If you want to do something, you need a strategy, how to get there. And there is plenty of strategies which you can use to defeat Germany. I will try to not make this mistake again. One of them might be that somebody said, let's use parachuters. Parachuters looks like pretty nice. They are effective. They drop from the sky, and it's a really good idea to use parachuters in the army. And then maybe there was a Harvard Business Review back then, and they said like parachuters are really effective and they support long-term strategy. And if you take a look at the blogs, which were in 40, 45, so they said that, yeah, this is the way to go. Infantry is dead, tanks are dead, parachuters are the way to go. So one way of choosing things, how you are doing things and what you are working on is to listen to the others, but then you might find out that they have also some other opinions, like earlobes are really effective way to measure like somebody's how successful. So this doesn't give us a lot of belief in their opinion. We can ask consultants, and you can go and ask strategy consultants. I will get back to it. Later you can check this link, which is really interesting. But there is a lot of what you can tell about strategy consultants, but mostly they are giving the answer which is, let's say, vogue. Or you can take a strategy of doing what everybody else are doing. When you are playing chess, your opponents move pawn forward, you move pawn forward, you repeat every move. In one of few games, you will win, but the question is, does it work every other case? Repeating what everybody else are doing. Or, in case of Dwight Eisenhower and ours, you can use map. Because map is giving us a visual representation of what is going on in our environment. So we have a target, it's visual, so we can see how we are moving, and then we can see what is the terrain, that here is the river, and maybe because here is the river, we want to take this place. So it really makes sense to use parachuters. And with something like map, which is visual, which gives us a context, which shows us where we are moving, we can make some strategy moves and adopt this in life, in technology. And by now you might be wondering why I'm talking about it to you and what is the map. So getting back to the link and strategy consultants, this link which I gave you is generating a strategy for every company. So if you will be starting a company, you can go there and with every refresh, you will get a new strategy. And the funny part is this was written by Simon, that he made a trial. He generated a bunch of strategies, sent it to 200 companies. 180 responded, how do you get our document? Because most of the strategies companies are using are something like this, a lot of blast with words, which basically doesn't mean anything. But if you will think about it, you can really say how to do something or where to move with your technology, with your choices, when you have first context, which if you will think about it, every our project or every technology move starts with the context of the user. There is a user has a need, we satisfy it. If you are doing something not to satisfy user needs, the question is why to do that at all. And then it's a position, so the question where we are, where we're starting, where we are going, where others are on the map, how they are moving, and this creates a kind of situational awareness. And let's use a map to analyze something like a cup of tea. So if you want to drink a cup of tea, we have a user. User wants to drink a cup of tea. To make a cup of tea, we have a tea and a hot water. To make a water hot, we need to use something like a kettle. And then maybe we need the power to power it up, to boil the water. And if you will use user as the anchor of this entire diagram, so this creates a position. Elements higher on the position are visible to the user. So this is something which users see when he's interacting with our solution. The lower it is less visible to the user. Yeah? Because when you are getting a cup of tea, you don't think how the power was generated to boil this water. Yeah? So this gives us a part of the equation, which is position. But then where is the movement? How those elements moves on the map? Where do we want to move with our cup of tea? And one thing which you need to be aware, if you are not thinking about it, everything evolves. And whatever we are doing, this evolves. Like this is being changed. And it evolves from something which is called the genesis. This is how it's defined in this notion, where genesis is something, I have an idea, but I don't know how to do it. Nobody even done it before. So we even don't know how to do it, but we have this idea. To the point of becoming a commodity. Like it is well known, well adopted, you don't think where it came from. Like the power, you plug the computer to the power plug and then you don't think how this power was generated. The energy company are saying it is green, but it's really green, you don't know. It's commodity, you don't think about it. And this creates a movement for us because all things on this map are moving into the direction from genesis to commodity. So whatever you are thinking right now as very unique, in some time will become a commodity or it will die, basically. And when you have this map, you can do a lot of interesting things with it because let's say that we are running a coffee shop which boils a tea in a very old kettle. And it's very old, ancient, we got it from our grandma. But all other users are using a kettles both in the shop, like IKEA. So the question is how we can scale our coffee shop if our business is built around this very old, ancient kettle. And this represents a technical debt because we rely on something which is very unique, where every other are using the same thing, but it's a product or rental, and they can build their businesses much quicker because they go to the shop, they buy a kettle, they can open a new coffee shop. When we want to open a coffee shop in our business model, we need to figure out how to find the old kettle. When our kettle will break, we need to get a new one, which is very ancient. And maybe we bring this idea that maybe we should use a kettles from IKEA. But then somebody says, no, IKEA is bad. So we will call it inertia. And inertia introduces a blockage in the movement. So when you will think about these movements on the map, you can really find a lot of ways how to analyze your current strategy, current situation. So we have a need for a strategy. We create a map to gather a situational awareness, like where we are, what we are doing. And the question is how it maps to the topic of serverless. And I hope I will explain it in a moment when I will open the bottle. Okay, so we have our roadmap, and here we have elements which are visible to the users, and here we have our evolution. And when you think about the concept of computing or computers, we had the users who had to have some application. The computer without application is basically useless. The user has to interact with it through the application. And at the beginning, both application and compute, the hardware which was used for that was a genesis, because people were building computers trying to figure out how to build them. The first computers was, as you know, huge. They were custom made. And we started to understand the concept of computing at all. But then, because everything evolves, so both the computers and applications started to move on this map towards custom build. So it wasn't figuring out if we can build a computer, but it was building computers based on the known principles. Just every computer has to be made for a specific customer. And the same was with the applications. But then, to standardize the environment on which those computers works, somebody introduced the operating system, and then every manufacturer was building an operating system for its custom-made hardware, which still wasn't effective, and it took a long time, and every time somebody was writing an application, they had to adjust to a specific OS, which runs on a specific hardware. But still, everything evolves, and over a time, operating system and compute become a product. So you don't figure out how to write an operating system, but basically you buy a ready product which works on a standardized, commoditized hardware, which you also buy in a shop, which started to the move to figure out how to build applications at all, and we started to create architectures. It wasn't that there was a three-tier architecture or whatever kind of architecture, like right now we talk microservices at the beginning. People had to figure out how to write applications on a standard software, on a standard OS, and then they can figure out architecture for it. So it wasn't given. The problem was that there was a high MTTR, mean time to recovery, because everything was custom. If your computer failed, you had to get a new computer, and then we had to figure out everything about high availability, scalability, and everything. But still, everything evolves, and computers move to the products, and the same architecture patterns move to the product phase, which means that they are well known. Nobody thinks about how to create high available environment. It's a cluster, let's say, just simplify it. But those architecture patterns started to be like a product. And evolution is going further, so computers are evolving more into the commodity, and architecture patterns also are evolving into the commodities. Yeah, because when we have computers and we have to put a high available database, nobody thinks how to do it. There are already patterns for that. Also because we had applications, somebody started to think about how to write applications in a repeatable way and how to create the frameworks. So people were started to create some coding patterns, and those turned into the frameworks, but everybody were like writing their own frameworks around that. But this also is subject of evolution. So frameworks were starting to be more and more productized. So we had the Java, we have a .NET. Those are the frameworks which were productized. And with that, we also started to have standard patterns how to write the software, to not figure out every time how to write the software on given framework. So basically, we created a set of common patterns how to do it. And they also become a commodity. So we have a compute, which is a product. We have a well-known architecture patterns. We have OSs, which are products. On top of those OSs, we have frameworks. We have a well-known coding patterns. And at the end, we have application. And then what happened? Cloud happened. But if you will think about it in this model, the cloud is only compute becoming a commodity. Because with cloud, what happened, nobody thinks about buying a computer, you rent a computer. Yeah? So it becomes a commodity. And because that introduced a new way of doing things, so we started to think about new cloud patterns, which eventually also become a commodity. But we also had the people who were saying you are not going to the cloud because it's insecure, it's whatever you want. You're not going to the cloud. And this creates some inertia. But this represents our cloud. This is a compute becoming a commodity, working already architectural patterns where we have a new to basically lower the MTTR. And those new patterns are called DevOps, because DevOps is basically a way to deploy ready known architecture on top of compute, which is commodity as a cloud. But then evolution was going further, and also OS become a commodity, because when you are deploying a cloud machine, you don't think how to tweak an OS. You deploy a machine with a ready pre-configured operating system, and basically somebody is doing this for you. And what happened next is a framework become a commodity, because right now you are just writing a code which is being executed in the environment, which is built from commoditized compute, commoditized operating system, a commoditized framework. And this is what we call right now serverless, because serverless is basically something which is visible to the user, which is a code which you create, which runs on top of commodities like framework, operating system, and compute, which requires, of course, new patterns and practices, which we call right now a serverless architecture. Eventually, those patterns and practices will also become a commodity, so we will start to think not how to write the software in a serverless manner, it will basically utilize it. And this creates a lot of interesting facts, because what we sometimes consider right now a new, actually, DevOps, a way how to deploy things on the virtual machines, how to containerize applications, are actually a bit legacy, because this is going to be replaced in the evolution patterns, but something which is right now emerging, which we call serverless. And serverless would not be about the Lambda or function or some serverless database, but it will be about new patterns and practices which will bring a bit better business value. And right now you think I'm a consultant, which is right. With this concept, you can analyze a lot of things, but first of all, what is serverless? And we'll get back to this definition. I think I will finish early. So serverless is an application which generates a business value with no cost if nobody is using it. How many of you are writing like full serverless applications right now? Few. Okay, because to my surprise, when I was last time doing this talk, everybody was surprised with those numbers. So let's talk a bit about the cost. Who of you know have I been pound? Yeah, each of you, or most of it. For those who don't know, if you will not remember anything from my talk, just remember have I been pound, go there and check your email. This is a website which checks your email against the list of breached passwords. So basically, you can detect if if your password was leaked in some data breach. And it's built by a single guy, Troy Hunt, and Troy built it completely on a serverless. So it is built on top of Azure, and let's see some numbers. So Troy has published numbers in June 2018, how much it cost him to do 45 million queries on top of 500 million passwords. And for a month, it cost him $32, and per week it's $7.4. And to make it in scale, having been pound is who is using Firefox? Because when you are using Firefox, every time you enter a password into the Firefox, it is being checked against have I been pound. And the same with applications like 1Password. So entire Firefox user base is hitting this application, and it still costs $7.4 per week. But a few months later, Troy did something else and introduced the Cloudflare as a cache in front of the have I been pound. And then his cost right now is 2.6 cents per day. In total, it's $0.7 per month to do 141 million queries per month. So, this is an application in a scale built on a new framework which is called serverless, which is all about the way you think about the stuff, not how you build them, which basically cost you like $0.02 dollar per day to run it. And he sells it as a subscription to the companies like Firefox. Brilliant business. when I was preparing to, by the way, I linked this article here. You can get it later and check all the details, how it's being built, how the Cloudflare is used, what is the code behind it. But when I was preparing to this talk, and that was a bit last minute because the organizer asked me to come, so I came across something very interesting. I found a guy from AWS world who shared his experience of building the serverless application. So we have a user, and a user is any of you who is managing a team, and then there is a challenge how to know who is at work, who has how many vacations, and basically tracking and managing vacations. And those are the user needs. And Slobodan Stojanovic, he's an author of this, and he's also an author of those pictures I will be using. I promised Slobodan that I will refer to him. You can find him on the Twitter. And he built an application for that. So we have the user need, and we have a component which user is using to satisfy those needs, like calendar, spreadsheets, different communication channels, to talk with people and ask them, hey, when you are on the holidays, or to check if this person is at work or this person is on holidays. So we have a user need, and some complicated work. And Slobodan thought that this might be made simple, and he mapped those needs over this map, as I said. So basically what this tells you is that this is a user, those are the user needs, those things are custom built, it's hard to replace a direct communication. Those things are commodity, nobody thinks how to write a new email server, whatever. But he thought that maybe he has a space there, how to satisfy it. And of course he did it. He created something which is called Vacation Tracker IO. And he built his application, but what he chosen to do is to use a serverless approach. So instead of building all of it, like having a virtual machine, containers, whatever, he built his application here on a serverless pattern, which basically is all functions and all serverless products. And instead of taking care about all of it, basically he focused how to directly satisfy a user need. By the way, you can find it on the internet. This is his architecture in a nutshell. And then his cost of running all of it is $10 for a 5.5 million requests from the users in a single month. He has 300 paying customers who are, the cost of running this business is $10 in the infrastructure, and it is being run by 2 persons only. And this is really interesting. You can find the use case here as well. And you can say that this is nothing new because you're doing right now this everything with the containers, and containers are actually doing the same thing. And I'm more than aware that the containers and Kubernetes is like a kind of main theme here on the conference. So let's look. So isn't the Kubernetes doing the same thing? Like this allows us to write application quickly. It allows us to abstract the hardware. So isn't the serverless that different from the Kubernetes? So first, let's think why we have a Kubernetes. What was the reason for a Kubernetes? And the main reason for Kubernetes to exist or to start, in my opinion, that's my point of view, you can disagree with it, was that it was created to make use of hardware more efficient. So basically, that was a better way to utilize hardware in the server rooms than running the virtual machines, because you can assign a smaller chunk of it, make it more efficient. Then what we are hearing is that Kubernetes increases developer productivity. And it's cool, that's obvious. Yeah, everybody are using it right now. Even I'm using it from time to time. But is it really true that the Kubernetes is making developer life easy? Who agrees with that? It's serverless track, so that was easy. When you think about Kubernetes, before developer will start to create application, before developer will start to even think about providing some value application, they have to at least familiarize themselves with all those terms. Yeah, I know that Gutek he had a session 2 rooms from here, and he's explaining what is the pod, what is the node, what is the master node, and all of it. Yeah, but the question is how important it is for your application, what value it brings to the user, and we haven't started to talk about the updates of the clusters. Yeah, by the way, what's important for you is to know that the cluster exists at all as a developer and as a creator of an application. Because when you will think about it, when Slobodan was creating this application, so he had a user need in mind, and he know that he can satisfy it. The question is where Kubernetes fits into this picture when you are creating an application. And when you will think about it, this is the application where exists in this world, but Kubernetes is here. It's in a someone else's problem landscape, because for user, it doesn't matter if there is a huge, pretty neat, tightly configured Kubernetes cluster and you can do, I don't know, 100,000 of deployments of your container on it. As long as it satisfies the user need, he has to go there and create a vacation request. So Kubernetes is actually an infrastructure piece which doesn't have a lot of value from the business perspective. If I will create an application on the virtual machines or on the Kubernetes for an end user, that doesn't matter. Okay, maybe it will cost a bit less, but the question is how many people you have to handle the Kubernetes, and there are good cases on it. How many people you need for a serverless application, how many people you need for a Kubernetes-based application. So if this is a commodity, or it will be soon, because if you will track all the investment across all the cloud vendors into the Kubernetes, so they are going into commodity. If it's commodity and if it doesn't bring any value, so why bother with it? That's the question you have to ask yourself. And I even brought here Tomek. Tomek is no, he decided to listen about Kubernetes because I tracked Tomek on our social media. By the way, very good content, very good articles about Kubernetes. And one of the blogs on articles on his blog was that Kubernetes won the war. But for me, based on those maps and everything which I think about it, the question is, was it winning the right war? Because it won the war on the infrastructure, which will become a commodity. And pretty soon, or maybe a few years from now, you will not think about the infrastructure at all. You will basically deploy your code. So right now we are creating 2 tribes, which basically some way in the future will converge and will become a one tribe. When you will think about it and when you will look at the current where the vendors are going, so the vendors, especially the cloud platform vendors, I don't control my time, so I need to, yeah, okay, because it's switched off on my, so if you will take a look at the cloud vendors, and if you will think about this concept of visibility to the users and evolution of every component, so what vendors are doing, they look at what you deploy, they think how to create a higher level value from this, what you deploy, how to create a service which will be higher in this value chain for you to start to use it. That's why they work on a serverless containers, because maintaining containers is basically, or managing the Kubernetes clusters is a cost which doesn't have to be there, and that's why they are creating things like this. And you will see more and more of this movement to the point that containers, virtual machines, and everything will become obsolete, and you will not think anymore about it because there is no value in it. That's my value proposition for you. So the question is where you should focus and what you should look at for a future. And I strongly believe that maybe this is because there is a well-known friend, Łukasz Kałuża, if you know him or not. If you will ask Łukasz, and I have a permission to say that, if you will ask Łukasz, maybe he doesn't remember, but I have a Facebook chat, why you're doing a Kubernetes, and he's saying Kubernetes is a very good way to hide developer incompetency, but it also allows me to earn pretty good money, so I will work with it. Yeah. But if you will think long term, where you can invest or should invest, and there are some people who are doing this already, you always start with the user need, and that's the key. And it's a very good question, and I started to learn this and have this exercise, first of all, to ask, who is my user? That's a very good question. It's not that obvious, yeah, because that's the question. Okay, who is the user of this application? If you work internally for other team, that might be your user, yeah. And this user always has a user need, and that is your anchor. You should look, okay, so this is my user, this is a user need, and how my solution contributes to satisfying this user need. when you will think about all of it, what I call a new legacy, like a compute operating system, architectures from this compute, and then you will think about serverless. So this is all somebody else's problem. It's a vendor. Why you want to deploy operating system? Why you want to create the virtual machines? Why you basically need to bother with the network? What is the IP address? Why to think about it? And then we have application and coding patterns, which are becoming what we know right now as a serverless. And just be sure, this will move to this side as well, and there will be something new. And this something new is already emerging. Because when you will think about it, serverless right now is starting to move, or there are some indicators that it is starting to move to the commodity. So we have a products which basically are moving what we consider right now as serverless functions, Lambda, lower down the chain, because we have a code repositories and API markets. So instead of even writing our own functions, we build a function on top of some piece of code which also runs as serverless. So he's working on AWS. Lambda layers, if you will think about it. So Lambda layers is here. It's basically a code repository in the form of binaries. And when you're writing a function, you're actually deriving this code from this other function, which is underneath. But to make it all happen, there are new patterns like serverless security. This is something which basically is like not well defined now. There is no like known way or well-defined way of doing it. And there is something which I'm pretty interested in, and this is a capital flow in an application. So because with a serverless, what you can do is actually you can track the cost of every call request in an application. And when you will visit this article I mentioned from Slobodan, he has a presentation, and he asked a very good question, like, what was the cost of your last bug? How many of you can say, what was the cost of your last bug in a code? And he says, we know it was $2. It was covered by the free tier of AWS. It didn't cost any problem to the user, so we decided not to fix it. Because we don't pay for it, it is not causing any problem. And this is what is capital flow. And all of them will also move towards the product and commodity, but when you will be first to invest in, you have a pretty good chance to build your career even on that. So when you will think about it, and what I'm looking into the serverless space actually, it's a transaction value-based development. How much it costs me to execute a given code path. Like you have an application which is issuing the invoice. How much it costs to issue the invoice to the point that I have a PDF with it? Can I replace it with some other function which will be cheaper, which creates a marketplace for that? Because there might be developers who are building a function to generate PDF, and they will get a fraction of what I'm paying to AWS for that. Yeah. Or what code refactoring, but based on the cost. How much will I save when I will move this code to something else? How much I can save on top of it? Code efficiency, this is what I said about this bug. Like if we have a bug and this bug doesn't cost us, this doesn't cost any insecurity, whatever, so why we should fix it? But at the same time, we might come to the developer and say, you know what? We are generating 3 million invoices per month, and we think that you can optimize this code call for 1 cent, multiplied by 3 million, this saves us some money. And monitoring of the financial flow in the application, this is a very interesting topic. And you might say that nobody thinks about it and it's not happening. But if you will track things on the internet, we have something like AWS Serverless Application Repository, which is basically, who knows that, by the way? Few of you. This is a repository of a serverless components which you can deploy on your subscription and start to use this serverless code written by others, which brings us to the coded repository and API markets. And if you need any of those functions, instead of writing those, you can deploy it on your subscription and start to use it in your application. And when it comes to the financial flows, on the AWS blog, by the way, my daily job is totally Microsoft. But to be frank, AWS is a bit ahead in this game. So if you will look for it, there is a set of articles from AWS about tracking a financial flow in the application, because with serverless approach, you can basically assign a monetary value, and then you can track how this application generates a capital flow. There is a cost to the user at the end. There is a cost of calling all those functions, and the difference is profit of your company. Changing some component underneath is generating a profit. And this is something which we will start to work more than writing just a code, because suddenly you can create an application for a business where there is no cost of running this application unless somebody is using it. And I will finish with a quote from Alexander Simonovich, that serverless is an abstraction level over a company's IT infrastructure, enabling product and engineering to focus significantly more on delivering software business value. And business value is a key here, because serverless is not about technology, but about writing a code which generates a business value. And I might be wrong on that. And Simon also says that all maps are wrong, all models are imperfect, some of them are useful. So I will encourage you to Google Simon Worldly map, and also with the serverless, and try it on your own. Try if you can figure out how it is wrong. If you want to ask me about it, my Twitter, the Onyszko blog on the company and personal, and that's everything I have prepared.
What is your take on the knowledge that we as a community, as engineers, gathered over the years, and the fact that this knowledge will be invalidated by this movement from Genesis to the commodity?
It will. I mean, we build, so it always, when you will think about it, it always is being built like you have some lower level components, and the sum of few of lower level components are building something completely new, and then we build new knowledge basically. So those are the emerging patterns which I was referring to. Nobody knows how to do, like so we tried at a company, we tried a few years ago to go to the customers and tell them that we will do a project on a value-based. We don't want to money upfront. We want to do we want to get a value from the deployed application. And you know what? They dropped it. Why? And this is also what you can easily show on the map, because they even don't know how to purchase it. There is no contract. There is no RFP. So we will have to build it from the scratch. And some people are building those patterns even right now. And basically there is a lot of movement around that. But this will be this is something which doesn't exist right now, and whatever we are using right now, when you will switch to this, part of your knowledge at least will be invalidated. It's an evolution.